Hello everyone, and welcome to today's webinar, Why Do Developers Choose Checkmarx? My name is Paul Curran, and I will be today's moderator. During today's webinar, we will hear from Andrew Thompson, a solutions architect at Checkmarx. Over to you, Andrew.
Thank you very much, Paul. Good afternoon, everybody. So, to start with, this fun slide is to illustrate the conflict that often occurs between developers and the AppSec team. So what's this conflict about? Well, traditionally, the AppSec team only get to start their work of checking security within an application towards the end of the SDLC, as this is when the application is normally up and running and can be subjected to penetration testing. This causes the developers problems though, as in their minds they've now handed the project over and maybe working on other projects with no time available for fixing found vulnerabilities. Additionally, fixing some of these issues may require substantial changes to the application architecture and are not necessarily therefore simple fixes. The conundrum then is how to test the application as early in the cycle as possible, whilst the developers are still working on it, and provide as much information about the vulnerabilities as possible so that they are easy to fix. In this WebEx, you will see that it is easy to start testing for vulnerabilities in your code right from the time the first line of code is written. We will see that Checkmarx can be integrated to IDEs and build systems, amongst other infrastructure, to be able to make scanning as simple as possible. One of the key concepts with Checkmarx is that the code does not need to be in a compilable state. Let's face it, once you have written all the components to make a system compile, it may already be too late for easy remediation of problems. So just throw your code at Checkmarx and let us check the vulnerabilities from day one. A quick question. Why are supermarkets or malls so popular? Because customers can go to one location to pick up all their shopping in one place. This is what Checkmarx does for the developer. We provide the best fixed location for similar vulnerabilities. By overlaying the attack vectors within an application, we show developers where to best spend their time. Fix it here and you will kill multiple birds with one stone. That's our aim. Checkmarx works with multiple languages, not just the old mainstream ones. We are also actively adding new ones on a regular basis. Recent languages include Swift and Scala. Additionally, if a new version of the language comes out, you don't need to wait for support for the new compiler to be implemented before scanning can recommence, as Checkmarx does not need that compiler to work. Have you ever wondered why scanning a large project still takes so long when only a few files have been changed? Checkmarx did. That's why we've implemented incremental scanning. Now, a scan triggered by a code check-in or perhaps your build does not need to take hours to return your results. You can get them in a fraction of the time of a full scan and with no loss of accuracy. As I mentioned at the beginning, user adoption is key to the success of any static analysis rollout. If developers are going to use a new tool, then it needs to fit in their way of working. We should not be expecting users to adopt working practices that Checkmarx dictate. To this end, we provide plugins for popular IDEs, so roles can be reviewed in a tool the developers are already using. We integrate to build management systems, so the process of scanning can be easily automated by an existing tool in the chain set. And we can display our results in other dashboards, such as Sonar, already using. Checkmarx acknowledge the fact that false positives will be found. It's a fact of life, but we do, however, believe that our customers should not live with them. Why do false positives exist? An example I like to use is where customers create their own sanitization routines for some data input. So whilst Checkmarx will know about sanitization routines that are available in frameworks being used, Checkmarx can be trained to recognize custom sanitizers, reducing or even eliminating altogether the existence of false positives. So you've scanned and fixed all the vulnerabilities in your code. Great. But what about the open source libraries that you've used? How secure are they? Well, Checkmarx has teamed up with Source to provide leading-edge open source analysis within the Checkmarx interface. This will identify the libraries you are using and let you know if they are susceptible to risks or out of date, or even if they have licensing issues. One for the project managers here. The result of using Checkmarx is that you can identify vulnerabilities at the earliest stage of the SDLC, when it is easiest and cheapest to fix them. And that is why developers love Checkmarx. What we have in front of us is the web browser interface to the Checkmarx tool. I'm logged in as the super user admin for the benefits of this demonstration, so I can see all the scans that have taken place. However, we integrate to your company's Active Directory or LDAP user management system, and then you can give permissions to the users and assign them to teams. So you can restrict access to what code they can see, and also whether or not they can trigger the scans. Now, first of all, I'm going to show you what constitutes a scan. I'm going to start off with the queries. So in the query viewer, we can see the range of languages which are supported, and in the tree structure, the provided out-of-the-box rules. So I'm going to have a quick look at the Java high risk and select the SQL injection. We can see here we've got a description for this vulnerability. What it is, how to avoid it, examples, and at the bottom links back to an organization that can tell you more about this in an independent fashion. We can also see what constitutes the Checkmarx rule in finding this. So in this case, we're finding our database inputs, our interactive inputs, sanitizers, and then where they all mix up. So where we find inputs to the database that haven't been sanitized, and then obviously return the results to you. But we're not expecting you to run individual rules. So we provide what we call presets. A preset is just a collection of associated rules. So they might implement industry standard rules such as the OWASP, or perhaps the HIPAA rules, or PCI DSS. Now, these rules and presets can't be edited. However, they can be utilized as the basis for your company or project coding standard. So for instance, if I would like to take the OWASP top 10 and use it as the basis for my project, I will duplicate that, give it a new name, and now I can add or remove rules from this. So if I perhaps were working with Objective-C and I want to implement best coding practice along with everything else, I'll tick that box, click Save, and this is now available to my entire team to work with. So let's create our first project. It's obviously not the first one because I have run many others, but for the purpose of this demonstration, we give it a project name. We choose the rule set which we've just created and which team we're going to run this under. So I'll choose digital services for this. Click Next, and now we can choose where our source is going to be selected from. I can choose local, which is a zip file of my source code. And that zip file does not need to include jar files or other third-party DLLs, which a build system would normally require. This is just literally the source files. Or I could perhaps pull it from source control, where we can integrate to a number of standard source control systems such as TFS, Subversion, Git, or Perforce. Let's select this. And then there is the route, so I can select which files I want to scan from within here, click OK. Now I could click Finish now and just scan, but let's have a look at the other options. The default is to run the scan now, or at least add it to the queue. I could also, though, schedule this to run at a future date or time. And finally, I could elect to receive an email when the scan starts, finishes, or if there's any particular failures. So let's click Finish on this. And that is now adding this to the queue. Now the queue is a first come first served basis, but the fact we add that we can use multiple scanning engines means that we can also apply filters so that you can reserve particular scanning engines to work with perhaps large build server initiated projects, whilst keeping a dedicated server available for smaller IDE initiated scans so that your developers get quick results. Now this is on the queue now, but will take a little while to run. So in a Blue Peter fashion, I'm going to go to one that I created earlier. And what I'd like to do first is look at my Bookstore C# project. I can see here that I've got a total of 2 scans on it so far. And if I come down to the bottom, I can still see that my project is sitting right up in the dangerous top right quarter of my heat map. But I can also see that from subsequent scans, the number of issues, or certainly the number of high-level issues, is reducing. So let's have a look at the results here. So in this particular view, again we can see that the risk level score is reducing. So before I look at the actual results, I'm quite interested in understanding what has changed here. So I'm going to select these 2 scans and have a look at the Compare Scans option. From the high-level results, we can see that the number of lines of code has pretty much stayed the same. The preset has stayed the same, but we can also see that a number of vulnerabilities have been removed. Now, why is that? I'm a little bit curious, so open up the results. And I can now see a diff view of the old and new code. By filtering my results, I can look at the fixed vulnerabilities, and here I can indeed see that whereas the old code returned a straight string, I'm now applying an HTML encode routine to it, and this is why the vulnerability has been fixed. So it's a good way of checking to see how other developers maybe have fixed similar vulnerabilities. So I'm now going to close this down and look at some of the actual results. So you can see instantly that Checkmarx has detected this is a C# program with some JavaScript in there as well. This is picked up automatically for us. We've also split these out into the high, medium and low vulnerabilities. And by selecting the SQL injection here, I can see what I need to fix in this area. So I could pick individual vulnerabilities and I'll see the attack vector, and by clicking on various elements I can see where they are in the actual code, including the source and the sync points. I've got 25 vulnerabilities here. Maybe I don't want to have to go to the hassle of fixing all 25 individually. So this is where Checkmarx introduces the concept of the best fix location. Now we can see this in the graph view. I'm just going to expand the view here. So this is the attack vectors for all of those 25 SQL injection attacks. But we can see with the red boxes, these are our best fix locations. So I now have 3, 4, 5, 7 areas that I can fix, and by rectifying those 7 areas, I resolve 25 vulnerabilities. So this is our multiple birds with one, or in this case, 7 stones. So when the vulnerabilities are displayed to us, they will all be initially in to verify state. And one of the first stages might be for your team to have an assigned reviewer to come and check whether these are exploitable or not. And they will then either mark them as confirmed, maybe urgent to fix, or they think, maybe this can't actually be exploited. Now, that might be because it's a true vulnerability, but it literally can't be exploited, or maybe it's a false positive, and we'll pick that up in a little while. But if you've noticed over on the right-hand side, I can see that this has been assigned to particular users. So we can assign a few more, and we'll save it to Mr. Dave Demo to go and fix. When we do that, we also add a comment automatically to the history for this vulnerability. As a reviewer, I can also add my own comments, hopefully with something a little bit more subtle than please fix. Now these comments stay with this vulnerability for its lifetime and can also be seen within the IDE. We can also change in here severities so that we can make things more applicable to our own environment. So let's have a look to see what these results look like within an IDE. And within IntelliJ, I can submit a scan, or I can retrieve results. So if I've been notified that the overnight or the build scan has some errors, now this SQL injection, I can see my results, I can see my graph view, but those of you who are eagle-eyed, you can see that actually I'm sanitizing this input. So this is one of our false positives that we need to rectify. So I would report this to my security champion that is in charge of fixing the false positives. He would then use, or he or she would then use, the CX audit tool. This is what we now see in front of us. And I can analyze the same project with the CX audit tool and run the same SQL injection attack to get results. So here's my 3 attacks, and as we can see, here's my sanitization routine not being picked up. Let's look at this in a little bit more detail. So I'll bring up my SQL injection query. We've got our find database in, our find interactive inputs, and find sanitize. So it's fairly logical to conclude that my custom sanitize routine method is not being picked up by this. Quite understandable, since it's my own custom routine. So what we're going to do is override the results of find sanitize. We can do this in Java General, and right-clicking and override for all projects. So I'll show you one which I've done earlier. Rerun the SQL injection, and it now recognizes my custom sanitize routine as a valid sanitizer therefore not susceptible to SQL injection attacks. So obviously, once I then rerun my tests within Checkmarx, these SQL injections would no longer be found. Neither would any other vulnerability which is using the same routine. Now, SQL injection is a commonly known vulnerability, but let's take cross-site scripting. Maybe I'm a new developer and haven't heard of this before. How do I learn about it? Well, within the browser or within the IDE, I can select the question mark, and that then pops up our description. Now, I'll be honest, Checkmarx would like, within 2 years of implementing our tool, for not to be finding any vulnerabilities in your code at all, due to the fact developers will be learning from the documentation and the links to other external documentation about these vulnerabilities, and therefore not putting them in the code in the first place. Back to my projects, and we see that down here we've actually got some projects which I've triggered from a Jenkins build. So let's have a look at the integration to Jenkins. So we provide a standard plugin for Jenkins that can be downloaded from the Jenkins site or from our own web page. When this is added, I can configure projects to have a build step where we do the scan. So I'd give it our project name. I can choose my development team that I'm working for, and as with all scans, I can also exclude folders. So for instance, many projects will have test code, some unit tests perhaps, which you don't want to scan for security vulnerabilities. So I could exclude those from this scan. I can also implement an incremental scan, so that when I do my build, I'm only scanning the code which has changed and reducing that scan time. But it is also good practice to schedule a periodic full scan, so that either after every 10 scans or perhaps every 5 scans, I will run a full scan of the code to reset my baselines. I've also got the option of running an asynchronous scan, such as the build system will trigger the scan of my code, but it's not going to wait around for results, and it will carry on to the next build step. I can also put in thresholds, such as if the number of high-level vulnerabilities exceeds certain levels, then it fails the build. So if my policy is to not accept any more than 5 high vulnerabilities, 10 medium, and maybe be generous 50 low, then if either of those thresholds are exceeded, the build would fail. Similar functionality is available for other build systems. We integrate to TeamCity, TFS, Bamboo, etc. Can be fed back to Jenkins as well. I haven't run multiple scans, so I don't have my trends, but I can see my detailed report within here, the number of high-level vulnerabilities, and also links back to the code itself within our browser. So we've seen so far how we can create a project, either directly within the browser, or that can be done from within Jenkins itself. We've scheduled a scan. We've then been able to access the results, remediate the vulnerabilities, distribute those to users to fix, But we also mentioned about the other aspect of the scanning. Maybe my code is completely secure. What about the libraries which I'm calling? What about the open source stuff which I've been using in my project? So let's have a quick look at our project dashboard for a minute. I'm going to select one of my WebGoat OSAs here. So we can see a couple of high-level graphs for my project, but also in the open source side, I've got 4 libraries which are being shown as vulnerable. Let's have a look at our report for this. So there's various sections to this report. High-level summary, showing we've got 4 outdated libraries here. And within those libraries, we've got various vulnerabilities which need to be reviewed. We can also see our license risks for these particular libraries which we're using, what licenses are in use and what we need to comply with. Libraries that need updating. High-risk licenses where perhaps royalty fees are due, something which your legal team will be extremely interested in. And finally, the inventory of all the libraries which we're using. So how hard is it to run this analysis? And within the configuration for this project, we simply point the tool to the directory, perhaps on the network, perhaps local, where we're keeping our open source libraries for this particular project. Then I can then run the open source analysis directly within this tool. This does work, however, require access to the internet, is that we are taking a fingerprint of the files being used, and that fingerprint is being sent to the open source analysis server. No evidence of who is using those libraries or the names of the libraries themselves are sent over the open wire. Then the results of that analysis are sent back to Checkmarx to display, and it takes just a few minutes to do, but provides you with the complete analysis of your source code and the open source analysis. There are going to be some people that would like the odd report to read for bedside reading, or perhaps to log away for an audit trail. You can create a report and then customize what information we want in that. So remove a lot of the noise for the medium and low vulnerabilities. Perhaps I only want the high severities as well, and ones which have been issued to Dave and Dicky developers there. I also got the option of having an OWASP or PCI report. We can generate these in PDF format, RTF, CSV and XML. Let's generate one of those reports. That is now going to download. Do this, and we've got a high-level summary, some graphs in lots of colors for the management. But further down, we've got actual remediation advice if I want to distribute this to a developer to fix, with descriptions, links back to the violation within Checkmarx, where to find this violation within the source code, and snippets of the actual code itself. So hopefully enough information to fix this violation. So just to cover again the 3 unique selling points of the Checkmarx tool. We can reduce your scan times with the incremental scan. No need to scan the whole code base every single time. just change a few files. That will do. We overlay that on the top of the results from the previous full scan. We can show you where to fix the vulnerabilities with the most efficiency. If it takes the developer half hour to fix one violation, then you want to be being the most efficient and using the best fix location for the items in red to remediate the results, so you don't have to fix everything else in blue there. And the third USB is that you can scan this code from day one. From when you generate your first file, you can scan that. You do not need to have a complex build environment for Checkmarx to work. Forget about complex, you don't need a build environment at all. Just throw us the code and we'll do the rest.